Welcome to qnawire.
So here in this problem we are given this uniform chain of length 8 meter and it is lying on this horizontal table. Now there are two parts in the equation. We'll be solving the A part first, and in the A part we have to show that the chain will going to slide off the table if at least 3 meter of it hangs over the edge of the table, and the coefficient of static friction between the chain and the table we are given as 0.6. Now we're going to proceed with the solution. So we'll be applying the equation of equilibrium in the vertical direction first for this portion of chain. So there are only two forces acting in this portion, that is the mass m. Let the mass of this chain be m2 and let the mass of this portion of chain be m1. So we'll be applying equation of equilibrium here first. So we can write that m2g minus t would be equals to 0, because only two forces would be acting in this portion, that is its weight m2g and the tension force in the upward direction. So this is equation 1. Now next I will be applying the equation of equilibrium for this portion of chain. So let me draw the free body diagram for this portion of chain. So this is the normal force that would be acting N, and this would be m1g, and here it would be the tension force, and the friction force would be acting in the opposite direction. Now we can apply the equation of equilibrium in the y direction, that is sigma Fy equals to 0. So in y direction we have only two forces, that this one and this one. So we can write that N minus m1g is equals to 0. And next is sigma Fx equals to 0. So we can write that T minus Fs is equals to 0. So this is equation 2 and this is equation 3. Now we are assuming that the chain is on the verge of slipping. So static friction Fs would be equals to mu times N, and here N would be equals to m1g from this equation. So mu times, this is coefficient of static friction mu s, times N we have m1g. So this is m1g. And from here, from this equation, we can say that T would be equals to m2g. Now we can plug the value of T here and Fs here. So we'll get T, we have m2g minus mu s times m1g. So from here we'll get the value of m2 as mu s times m1, and m2 would be equals to mu s is 0.6, so 0.6 times m1. So this is the relationship between m2 and m1. Now next we are assuming that the mass of the chain per unit length is lambda. So total mass m2 plus m1 would be equals to 8 times lambda, because the chain is 8 meter long. So we're going to solve simultaneously these two equations, this one and this one. So we'll get the value of m2 as 3 lambda, and we'll get the value of m1 as 5 lambda. So from this equation we can tell that the chain will going to slide off the table when 3 meter of the chain hangs over the edge of the table. So this was the solution for the A part. Now next I will be solving the B part. Now in the B part we have to determine the speed of the chain when the last link leaves the table. This is the final position as you can see, and this is the initial position, and the coefficient of kinetic friction mu s we are given as 0.4. Now for a final position, if you consider this is a final position and this is we are taking to be the reference. Now for final position, the center of mass for chain would be lying at the middle of this, that is 4 meter from the reference. And for the initial position, the center of mass would be here. So this total length, it was 3 meter that we calculated earlier. So this distance would be 8 minus 3 by 2, that is 6.5 meter. Now we are assuming that X represents the variable distance the chain has slipped since the start. So length 5 minus x would remain on the table. So we can write that sigma Fy is equals to 0. Now there are two forces in the y direction, that is n minus m1g, and here m1 would be equals to 5 minus x times lambda times g is equals to 0. So we'll get the value of n as 5 minus x times lambda times g, and fk would be equals to mu k times n. So mu k we are given as 0.4 and n we have 5 minus x times lambda into g. So from here we'll get the kinetic friction Fk as 2 lambda g minus 0.4 x lambda g. Now we're going to consider the energies of the chain earth system at the initial moment, that is, this is the initial position and the final position. So we can write that Ki, that is kinetic energy initial plus initial potential energy plus change in energy, mechanical energy, is equals to the final kinetic energy plus the final potential energy. Now the initial kinetic energy of this system would be 0 because there is no motion, so Ki would be 0, and initial potential energy would be equals to the potential energy of this portion of chain plus the potential energy of this portion. So we'll get m1g times y1. So y1 here it would be 8 meters because its center of mass would be at 8 meters from the reference, so multiplied with 8 plus m2g times its center of mass is 6.5 integration fk times dx, and from initial position I to final position f is equals to final kinetic energy would be 1 by 2 mv square and final potential energy would be mg times this distance is 4 meter, so this is 4. Now I'm going to plug the values here. So m1 is 5 lambda g because initially this length was 5, so mass would be 5 times lambda, so 5 lambda g times 8 plus 3 lambda g times, because m2 would be 3 lambda, so times 6.5 minus initial position is when x equals to 0 and final position is when x equals to 5, and fk we have already calculated, its value is 2 lambda g minus 0.4 x lambda g times dx, and that would be equals to 1 by 2. This is the total mass. So total mass is 8 times lambda. V square we have to calculate plus m is 8 lambda g. M is 8 lambda because the total mass is 8 lambda. So times g and times 4. Now we're going to further simplify it. So we'll get 40 g plus 19.5 g minus 2g integration 0 to 5 dx plus 0.4 g integration 0 to 5 x dx is equals to 4v square plus 32g. We have cancelled lambda from both the sides of the equation. Now we're going to further simplify it and we'll get 27.5 g minus 2g times this integration would be x, so x and limit is from 0 to 5 plus 0.4 g, this is x square divided by 2, and the limit is from 0 to 5 is equals to 4v square. We have taken 32g towards the right side. So finally from here we'll get the value as 22.5 g is equals to 4v square, and from here v would be equals to 22.5 times g is 9.80, so 9.80 divided by 4 and square root. So from here we'll get the value as 7.42 meter per second. So this is the answer for the B part. So I hope you have understood the problem. Thank you.